Okay, all right. So now you may wonder, why are we solving problems of annuity, mortgage, interest? We're not in the business of buying or selling houses or renting houses, right? So why have we done everything we've done so far? What is the purpose of all of that in process economics?
Those are the basics.
Okay, very good. So yes, those are the basics. And I like to use the kind of problems that I have used so far because I think all of you find these more appealing. You can kind of you can have a better feel for these problems. And I think everybody just understands concepts better if they have a feel. All of you know what a mortgage is, even if you haven't really ever had a mortgage. All of you know what loans are. So all of you know what retirement is. So concepts like this. So that's why I was trying to use these kinds of examples. So today let me explain to you how this will factor into if you want to analyze the profitability of a plant. So if you think that, let's say that you want to start your own plant for making something, okay? Let's say you want to make a benzene, or you want to make ethanol. Let's say you want to make ethanol from corn, whatever it is. The question you're going to ask yourself is it profitable? Right? And you're going to only, of course, set up the plant if it's profitable. So what input do you need to figure out profitability?
Costs.
Okay, so let's start making a list. Cost of what?
Material.
Okay, cost of material.
Labor.
Energy.
Sorry?
Energy.
So the energy, let's call it utilities. Okay? Oh, actually what?
Yeah.
Insurance.
So utilities could be gas, steam, hot water, compressed air. All of these fall in the general category of utilities, right? Just like at your home. You pay one electric bill for utilities, right? Including gas, electric, water, right? So similarly, let's lump all the utilities into just one category. Okay, yeah?
Safety, fail safe.
Sorry?
Safety equipment, fail safe equipment.
Okay, but what is the general category for what you have just mentioned? Equipment, right? Shouldn't talk about equipment. We cannot use material, use labor, use utilities until we have the equipment. Yeah.
Real estate and like legal fees and stuff.
Okay, so you see I'm going to draw a line here. And equipment. And sorry, what did you say? What was the other thing?
Like the land, real estate, and legal fees.
Okay, land. Okay, legal fees, fine.
Transportation.
Transportation for what?
Your products
I-
or your
Okay, so transportation cost for the product.
insurance. Taxes.
So you can say raw material and also product, right?
Yeah.
Oh, no, isn't that material?
Okay, then somebody had a hand raised.
Oh,
Yeah,
I was gonna say insurance.
insurance. Okay, very good. And you will see in a minute why I'm drawing this line. Okay, what else? What about engineers? You're not going to have any engineers? You're just going to have labor? What about you guys? You don't any of you?
I mean, depends on what you're making.
Can we make anything without chemical engineers?
No.
No!
I can make my bowl of cereal.
What? Sorry?
I can make my bowl of cereal in the morning without chemicals.
But who made this bowl of cereal to begin
I
with?
haven't
Who made the
graduated, I
cereal?
haven't graduated yet.
But somebody made that cereal, right?
Would you
Very
consider
good.
building construction?
So engineers.
It wasn't a physicist.
Right? All the engineers here. Yeah. Okay, upkeep, maintenance. Right? So let's just say maintenance. Okay. Yeah.
Construction costs?
Okay, so equipment, construction costs.
Any type of repairs.
Okay, repairs which basically comes in maintenance. Yeah.
State and federal fees.
Okay. Okay, very good. So regulatory fees. And consulting fees, right? I'm just going to put it all together.
So on the product you make is taxed.
And yeah, taxes. Taxes. Very good. Waste treatment.
That's a huge thing, waste treatment.
Yeah, exactly. Yeah. Excellent. Yeah. What else? Yeah. Sorry.
Don't you have some idea of how much you're actually making off of what you're selling?
Okay. Very good. We'll come to that in a second. Yeah. Patent cost. Very good.
Advertisement.
Pricing. Okay. What else?
Sales.
Sales. Okay. Very good.
Gotta sell your product somehow.
Yeah, exactly. No, excellent. Yeah. I was just trying to say whether to put it right there or put it in a different category. But yeah. Okay. What else? Sorry? Right. The bribes are already in there. Right? That's how it works. No separate category.
Waste treatment.
What?
That's in waste treatment.
Italian? I can make jokes, right? Because I'm Indian, I make jokes about Indians. That gives me the right to make jokes about everybody. Feel free to tell me good jokes about Indians. But Indians as in the actual Indians, not the Indians from America. Why are the American Indians also called Indians? Sorry? Because Columbus thought he reached India, right? So he called them everybody. Yeah, somebody had a hand raised. Yeah. Okay, marketing and procurement. Okay. Marketing. Okay. Okay, so interest on loan. Yeah. Okay. Yeah. Okay, administration cost, which we can sort of lump it, but yeah. Now, actually, when we are done, would somebody mind taking a nice picture of this and sending it to me by email? Because that way I can pull it down. Because I will show you that interestingly, well, not surprisingly, but interestingly, you have pretty much picked on everything that we'll be discussing over the next class. But I want to actually show you that you have indeed picked on everything. But yeah, please keep going. Yeah?
Environmental fees.
Okay, environmental fees. That kind of goes in waste treatment, right? But yeah, sure, environmental fees. Okay, shh, yeah? Philanthropy, well, that comes in the end, right? The company doesn't do philanthropy. So, but yeah, if you want, sure. First, I have to say if you make money without philanthropy, right? Yeah? Healthcare, very good. So, healthcare slash overhead. So, these are called overheads, okay?
Does benefits fall?
Or benefits, yeah, slash healthcare slash overheads benefits. Overheads because it's so when somebody hires you, right, you are the head, but there has to be an extra money spent, which you will never realize your employer actually pays. Well, if you know your package carefully. A lot of times the retirement benefits, the medical benefits, all of that doesn't really go directly into your pocket. So you don't know. So those are all called overheads, yeah?
Taking clients to dinner.
Sorry? Taking clients to dinner. Okay? Sorry, what?
I said, yeah.
Yeah, sure.
Springers.
So we hopefully that's somewhere already, probably in marketing already. Marketing and advertising. Yeah.
Most companies make charitable donations.
Yeah, charitable donation, we already talked about it. So, we are doing the efficient analysis, right? So if you have money left over, you probably do that. But alright, I think we had a good point. So we had a good point. I think we really have covered all the important things. But now, first of all, can you tell me why have I put a line here in between? Very good. So these are called what are called capital costs. That means you have to spend that once in the beginning. And these are recurring costs or operating costs, whatever you want to call it. Yeah?
Our engineers and show insurance one-time fees.
Well, that's why I have engineers at both places, right? I have engineers here, I have engineers here. Right? In fact, I should also have labor both places. Right?
Labor should be recurring operating costs, right? If you don't operate, you don't have to pay labor.
Well, no, if you think about it a little bit more, how do you build a plant? Are you going to, what is chemical engineering? If you build a plant of for chemical engineering manufacturing, what do these plants have? Have you ever tooled have you guys tooled plants? Yeah. What did you see there?
Operators.
Huh? Only people? Only operators, nothing else? What is infrastructure? Come on, you guys are chemical engineers. You're talking like people on the road. If I ask them, what's a chemical engineering operation? I don't know, I see people there. I see people, I see smoke. Unit operations, very good. Now you understand why you do this course in unit operations. What are the most common occurring unit operations in chemical industry? Distillation, which is a specific case of separations, right? Separations takes away so much energy. Separation is a very big part of chemical engineering, right? So liquid extraction, evaporation, and yeah, of course, distillation column, liquid extraction and distillation column. Those are probably two of the most important ones. But yeah, what else? So yeah, separation equipment. What else?
Cooling tower.
Okay, cooling towers, very good. But cooling towers is a generalized case of
Reactors?
heat exchangers, right? Take heat out, put heat in. Right? What else? Reactors. Right? So yeah,
Pumps.
sorry, pumps, very good. Pumps, so this is, yeah, you guys are all getting it. So now, hopefully, you can start thinking about going back to your class courses on unit operation and start figuring out, okay, why did we do all those unit operations? Because you can think of chemical engineering as essentially doing really most of chemical engineering does 4 or 5 different things, right? And we already talked about that. Number one you can think of as reaction, right? Chemical industry in some sense is all structured around reactor, right? Reactor is the heart, because without reaction there's nothing else. But just like heart on its own, well, somebody could say brain is the most important thing, but either way, right? But on its own, heart and brain, they can't survive. I personally think all we are is our brain. And the rest of the body, what does it do? It keeps brain alive. Same thing with the rest of the unit operations. They are there to make sure that reactor basically does what it needs to do, right? So you have to bring in a product in a form where it can react. So sometimes you have heat exchangers right, to heat up the stream. Then you have pumps to pump everything in. Then you have control system to make sure the reactor stays where it needs to react, right? Fine. So all this is done, you have a reaction. You have your product. Can you sell this product? No, why not? It's not pure. So what do you have to do? Separations. A lot of times the stuff coming out of the reactor is too hot. What do you have to do first? Cool it. Well, if it's hot, you really want to cool it. Heat exchangers. Now, to take the stuff from reactor to the heat exchanger, will it flow on its own? No, what do you need? Pumps, right? So now you can start seeing why all these unit operations are so important, right? In addition to that, you have a few other things, like of course finally you need to, final package comes out, you need to package it, there are recycling streams to make sure the product that can be recycled gets recycled, and yeah, there's some waste treatment because sometimes the stuff we generate, we cannot really dispose it off. But yeah, that's sort of how you think of a plant. And so I'm actually really glad to see that although you guys kind of did a little bit randomly, but you basically managed to figure out all the costs. Now, the cost of equipment, right? How are we going to figure this out? Okay, we research, very good. So, costing, right? Costing is basically figuring out the cost of everything that is involved here, right? Where do we get this data from? Mostly by just doing research. Okay? But before we start doing research, what do we need? If we call a vendor, so let's say we call a vendor for heat exchanger. We say, okay, I want a heat exchanger. What's the vendor going to tell you? Yeah?
Price, retail price.
No, but he will tell you, what, are you crazy? You have to tell him a lot more. You can't it's not like buying tomatoes or potatoes, right? Okay, what's the rate for potatoes today? Right? You have to design a heat exchanger, right? And to do that, what kind of information do you need to design a heat exchanger? You first need to figure out what kind of heat exchanger. Shell and tube, floating head, right? Cooling tower, what kind of heat exchanger? Right? Okay, thin film evaporator. Well, thin film evaporator is kind of mass transfer and heat transfer. But anyway, point is, you got to first start with what kind it is, what is it, and then you got to start designing. What does designing a heat exchanger means? What does designing any chemical engineering equipment means? Like, you know, if you talk to an architect, he will have an idea what design means, right? If you ask a chemical engineer, what does design mean? What does that mean? Again, you're talking like somebody who's not a chemical engineer. Ooh. It's okay because none of you are actually chemical engineers. Ooh. You are in the process. What's wrong with you? You're a troublemaker. He's my buddy. He's my buddy too, so I can make fun of him. Well, all of you are my buddies. How about that? I can make fun of all of you. Yay! All right, so where were we? Sorry? What is design? Yeah. Yeah.
You're setting specifications to meet a desired product.
Very good. And what are those typical specifications?
Volume.
Volume is one of the most important ones, right? Volume for a reactor, area for heat exchanger, right? Flow rates for heat exchanger. So you need to know what does design really mean. Design doesn't mean you say, okay, you draw a line and 90-degree angle. No, it's 45, it's not perfect, right? Usually design means numbers. You can specify design by an actual diagram or design by a table. But yeah, you need to know design parameters for different types of equipment are different. The design for a distillation column is what? What would a design for distillation column require? Number of trays, very good. What kind of trays, right? Also, what else?
Reboiler.
Sorry?
Reboiler size.
Reboiler size, condenser size, reboiler, condenser. What else?
Reflux rate.
Reflux ratio, what else?
Partial or total condenser?
Okay, partial total condenser, what else? You're missing one of the most important things. Sorry?
Feed state.
Feed, where are you putting the feed? Right? Yeah, so all of this, and of course the flow rates, right? And of course the temperatures. And so yeah, so all of this information. So you can see that depending on different equipment, you have different design, different parameters that you have to specify. Fine. So let's say that you go to a company that designs all this for you. Let's say that you go to and typically that's how you do it, right? You're going to go to a consulting firm which is going to design the entire plant for you. Okay. After the design is there, how will they give you a design? Will they write a book for it? Like the volume of distillation column is this, the feed comes on 30th stage. How do they give this design to you? Very good, in diagrams, right? Because how are we doing on time? 3:40, okay, we have 10 minutes. So yeah, you know, pictures convey 1,000 words, right? It's just so much more true for engineering, right? Because anytime you have a diagram with stream coming in, out, you kind of right away you see what's really going on. If you see the same thing written in a paragraph, you can never figure it out. So yeah, there are diagrams to give these designs to us. What are these diagrams called? Very good. The process flow diagram is a more detailed diagram. What's the most elementary diagram? A block flow diagram, right? So typically when you start a design, even before you actually go to a real consulting firm, you start the design with blocks, okay? So block basically is just a reactor. Inlet stream, outlet stream, reactor. You don't talk about what kind of mixer, what kind of impeller, what temperature, right? You just say a block. Similarly for distillation column, just a block, okay? So why do you think you start with these very simple block flow diagrams? What's the purpose of that?
You can work around that.
Well, the first thing is, yeah, that already helps you. So that's a very simple picture, but already gives you an idea of what the plant will look like, just like an architect, okay? If you think about it, if you go to an architect and ask him to design a house, he's not going to put doors right away. He's going to do a very simple sketch of where the rooms will be, right? What it will look like from outside. Very simple one, so that you have an initial idea what it looks like. So the same reason in engineering. We kind of have a very simple picture, but there's another purpose, because this block